with synthetic division, how I want us thinking of this is, what makes this equal to 0? 1. So in this case, you're not going to have to do the long division as well. In this case, you just have to do synthetic division. We copy down the coefficients. Since x cubed is missing, we got to put a 0 as a placeholder in there. All right, the 0 is key. We're dropping the first term. That's automatic. And then it's multiplication addition. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Negative 5 and 2 is negative 3. Negative 3 times 1 is negative 3. 8 and negative 3 is 5. 5 times 1 is 5. Negative 15 and 5 is negative 10. Remainder, constant, x squared, x cubed. Where there's no sign, we put a positive. When there's a negative sign, you keep it. 10 over x minus 1. So it's remainder over the divisor. And that's my answer. The second one, I don't need to incorporate a 0 because I'm not missing any terms. 3 is what makes that equal to 0. 2, negative 8, 5, 7, negative 18. Drop the 2. 3 times 2 is 6. Negative 8 and 6 is negative 2. Negative 2 times 3 is negative 6. 5 and negative 6 is negative 1. Negative 1 times 3 is negative 3. 7 and negative 3 is 4. 4 times 3 is 12. Negative 8 and 12 is negative 6. Remainder, constant, x squared, x cubed. You always work backwards. So 2x cubed minus 2x squared minus x plus 4 minus 6 over that divisor of x minus 3. The cubes problems. We are using these formulas. If it's a plus, it's a plus b, a squared minus ab plus b squared. If it's a cubed minus b cubed, it's a minus b, a squared plus ab plus b squared. You need to know those formulas. Literally, I can only use one of 6 numbers. I can use 1, 8, 27, 64, 125, and 216. I'm not going any higher than that. I have to use perfect cubes. If this was 18x cubed plus 64, I couldn't do the problem. Okay? So here, my a cubed equals 27x cubed, and my b cubed equals 64. Therefore, my a is 3x, and my b is 4. And I'm literally just plugging it in. A cubed plus b cubed. So 27x cubed plus 64 would equal my a plus b. 3x plus 4. A squared, when you square 3x, it's 9x squared. Minus a times b. 3x times 4 is 12x. And then you add b squared. 14 squared is 16. This is your answer. You're just working off the formula. For this one here, a cubed is 216x cubed. Therefore, a is 6x. B cubed equals 125. So therefore, your b is 5. You don't incorporate the sign with it. You just plug the a and b into the formula. So 216x cubed minus 125. A minus b, 6x minus 5. We square the 6x for the ax squared. That's 36x squared. Plus a times b, 6x times 5 is 30x. Plus 5 squared is 25. And that right there is your answer. I'm looking for my ending behavior, my max, my min, and my zeros. We plug the graph or the equation of the polynomial in. and then we look at this graph, if you notice, as the graph goes to negative infinity on the x-axis, it goes down to negative infinity on the y-axis. As the graph goes left, the graph goes down. And as the graph goes right, the graph goes up. This is going to be the case every single time we have odd degree with a positive leading coefficient. When the x goes to negative infinity, the f of x of the y is going to go to negative infinity. When the x goes to positive infinity, the f of x of the y is going to go to positive infinity. Now, we're going to look for local maxes and local mins. The extreme max and the extreme min are infinity. The extreme max here is infinity, the extreme min is negative infinity. But we're going to look for basically when the graph turns. So, we want to be careful we get to the right point. I'm going to have you round to the nearest tenth. So, negative 1.8 and 0.7 is my maximum. Negative 1.8 and 0.7 is my max. My minimum is when the graph turns back upwards. So I come down here, and I click on that, and we get 2.1, negative 56.1. So that's my minimum. 2.1, negative 56.1. The zeros are simply where the graph crosses the x-axis. So it crosses the x-axis at negative 2, negative 1.5, and 4. So our zeros, negative 2, negative 1.5, and 4. So when I put this into my Desmos, my leading coefficient's negative, my degree is even. So as x goes to negative infinity, my graph goes down to negative infinity. As x goes to infinity, my graph goes down to infinity. So both of these, when you have a even degree and a negative leading coefficient, the y goes to negative infinity, whether the x goes to negative infinity or infinity. In terms of my maxes, with the degree of 4, I'm going to have two maxes that are local. I'm going to have one extreme max. We're going to write down the local max. So negative 3.9, 98.2. So negative 3.9, 98.2 is one local max. And my other local max is also my extreme max. Okay. So here, the extreme max essentially means you're not going to get a point higher than it. That's the top point. 1.8, 142.6. So 1.8, 142.6. And what I'll have you do is circle the extreme max. Now the minimum, the extreme minimum, is just going to be negative infinity. But we do have a local minimum. And that local minimum, if we scroll out here, is right here. This is the local minimum. Negative 1.2, negative 17.9. Negative 1.2, negative 17.9. That is a local minimum. And then my zeros, I'm just following along on the graph where we cross the x-axis. Negative 5, negative 2, negative 1/2, and 3. Negative 5, negative 2, negative 1/2, and 3 are my zeros. When we plug in to the graph a leading coefficient that's positive and an even degree, the graph is going to go in the same direction regardless of which way the x is going. So as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to infinity. It follows along. Now on this one, both these are going to be positive infinities. I'm going to have 2 mins and 1 max. 1 min is going to be the extreme. That's the actual lowest point. Negative 1.6, negative 3.9. Negative 1.6, negative 3.9, and I'm going to circle that as my extreme minimum. And then we're going to go 1.3 and negative 0.9 as my other minimum. 1.3, negative 0.9 is my other minimum. My maximum, and these are local, is going to make sure you don't do the y-intercept. You got to make it like that's the y-intercept. You got to take the max, which is negative 0.1 and 6.0. So my max, that's local, negative 0.1 and 6.0. And then for my zeros, once again, just following along the graph where we cross the x-axis. Negative 2, negative 1, 1, and 3 halves. So negative 2, negative 1, 1, and 3 halves. So we have the negative leading coefficient and the odd degree. So as x goes to negative infinity, y goes to infinity. As x goes to my infinity, my graph goes down to negative infinity. So in this one, we go in the opposite directions. X goes to negative infinity, y goes to infinity, x goes to infinity, y goes to negative infinity. In terms of my max and mins, I only have one of each, and they're both local. So my minimum, negative 6.1, 8.0, negative 8.0. So a minimum, negative 6.1, negative 8.0. My maximum, once again, going right off the graph, we're going negative 0.6, 73.2. Negative 0.6, 73.2. And then my zeros, where is this thing crossing the x-axis? Come on down. We're looking at negative 7, negative 5, and 2. Negative 7, negative 5, and 2. And those are our zeros.